So in this question, we're told that the triangles in each pair are similar, and we're asked to find the lengths of the unknown side. So I think what we should do here is start by labeling the corresponding sides. So we've got side PR here, which is 15 centimeters. It goes between the circle, the angle marked with the circle, and the X. So this one has to be corresponding to this one, which goes between the circle and the X. Similarly, side PQ here goes between the circle and the check mark, corresponds to this side over here that goes between the circle and the check mark. And this side here obviously has to correspond to this side here because those are the only two left. Once we've got this done, we can set up our proportion, knowing that the lengths of the corresponding sides are proportional. So again, we'll set it up with the small sides in the small triangle on the top, and the sides in the large triangle on the bottom. So let's see, we've got side PR, which corresponds to ST. We have got side PQ in our small triangle, which corresponds to side SU. And then finally, RQ corresponds to TU. And then we can fill in the information that we're given for the side lengths. So PR has a length of 15. ST has a length of 20. PQ has a length of 20. SU, we don't know. That's our T. RQ has a length of 25. And TU has a length of, oh, that's another one we have to solve for. That's going to be S. So to solve for T and S, what we're going to do is we're going to take this proportion, this three-term proportion, and we're going to pull out two of the terms and then solve. So if we're going to solve for T here, we want the terms involving the 15 and the 20 because it's the one with the two numbers, and then the one with the unknown. So we're going to solve this proportion. And of course we do this by cross multiplying. Okay, 15 times t is going to give us 15t. 20 times 20 is going to give us 400. And then we're going to just divide both sides by 15 to isolate t. T is going to be, let's see, 400 divided by 15 is 26.67 centimeters. So there's the length of one of our unknown sides. Solve for. To solve for the length of the other unknown side, we are going to use, well, we've got to use this term here because it's got the S in it. That's what we're trying to solve for. And we want to use this term again because it has two numbers in it, the 15 and the 20. So we're going to make a proportion that looks like 15 over 20 again is going to equal 25 over S. And same thing, we're going to cross multiply, and then we're going to solve for S. 15S is 20 times 25 is 500. Again, we're dividing both sides by 15. So S is going to be 33.33 centimeters. Punching that into our calculator. Okay, so we match up the corresponding sides, we set up our proportion, and then we solve our proportion. So let's do another one. Here we've got our two triangles. Let's just make this a little bit smaller here so we have more room to work. Now let's start by figuring out which of our sides are corresponding. In our small triangle, we've got JK here. It goes between the two arcs in the circle. So two arcs in circle, it's going to correspond to this side over here. Then if we go from K to L, that side goes between the circle and the arc. So circle and the arc, that'll be that side right there. And finally, our last two sides have to match up. So we can set up our proportion here. We've got JK. This, of course, again, we're still doing this. This is our small triangle over our large triangle. Let's try that again. Small over large. So JK corresponds to MN, or KL corresponds to, KL has this X, so M, let's try this again. JK has the circle, so it corresponds to the one with the circle, which is MO. KL has the X in it, so X cross corresponds to, that has to correspond to MN. And then our last side is JL, which corresponds to the other one with the squiggle, NO. Okay, let's put in our given information. JK is 10. MO is, oh, that's one we want to solve for. That's N. KL has a length of, oh, that's J. That's one of the ones we want to solve for. MN is 18 meters. And JL is 8 meters. And NO is 12 meters. Okay, so if we want to solve, we want to break this up into proportions. We are going to use, like this is going to be the one that we want to use twice because it has the one with the two numbers in it. So the first one that we're going to solve is going to be this one over here. Okay, we're going to do J over 18 equals 8 over 12, and we're going to cross multiply, and then we're going to divide. So we're going to have 12J equals 18 times 8, which is 144. Divide both sides by 12. J is going to be 12 meters. Our second proportion that we're going to solve is going to involve 10 and N. And again, as I said, we've got to use this one again because it is our one with two numbers, numerator and denominator. So 10 over N is going to equal 8 over 12. We're going to cross multiply. Again, 120 is 8N. And then we are going to divide both sides by 8. 120 divided by 8 is 15. So N is going to be 15 meters. So again, cross multiplied in here. Okay. Okay. What do we need to solve for here? Looks like we've got a Y and we've got a W. Let's just start matching up our corresponding sides here. Between the circle and the check mark, I'm going to label that as that. Circle and check mark corresponds to this one over here. Check mark to X, check mark to X, and then the third side like this. So once again, small over large. In our small triangle, let's do the, and if we're really good at this, we can just go right to the proportions without listing the side lengths. So let's try that this time. In our small triangle, I've got, I'm going to go the circle side first, the one with the little circle. I know that that is 10 meters. The corresponding side in the big triangle is 16 meters. In my next one, the one with the two X's, I've got 15 meters. In the small triangle corresponds to W in the large triangle. And my last ones, the one with the squiggle, is Y in the small triangle and 32 in the big triangle. So we're going to use these two here first to solve for W. Cross multiplying gets us 10W. 16 times 15 is going to get us 240. And then we're going to divide both sides by 10. W is 24 meters. To solve for Y, we are going to use this one here and this one over here. Again, we've got to use the 10 and the 16 again. So 10 over 16 equals y over 32. We'll just indicate that that's what we've done here. And again, we're going to cross multiply. 32 times 10 is 320. 16y, divide both sides by 16. Y is going to be 20. So y is 20 meters. All right. This one, they haven't even labeled any of the vertices, so we're just going to have to use, we're just going to go straight to the proportions from this one, okay? And what we want to do here is we want to solve for side x here. Now, the trick in one like this is that x isn't, like x is this distance from here to here. So it's not a full side in our triangle. Okay, so we're going to have to do a little bit of extra work here, I think. But anyhow, let's try setting up the proportion. We've got a small triangle, we've got a large triangle. Our small triangle, we can see down here in the bottom. This is our small triangle down here. Okay, and our large triangle, of course, is inside, is the big triangle that we see. So they haven't labeled any of the angles, but what we can see, of course, is that the two triangles share this angle right here. So that angle is obviously the same between the two of them. Then if I look at, say, this angle here, it's going to be the same as this angle up here because this top side here is parallel to this one right here. So if those two are parallel, we've got a little F pattern in there. And that means that this angle and this angle are going to be the same. So let's look for sides that are corresponding then. This side and this side are going to be corresponding because they're between the X and the check mark. This side right, we'll use an X right here in our small triangle, is going to correspond to this entire side here, okay, in our big triangle. Same thing on the other side. If this is in our small triangle, we want this entire side here in our big triangle. So what is proportionate to each other? Well, the circle is obvious in the sides that I've labeled with the circle. So in the small triangle, we've got a side that is 2 meters, and in the big triangle, the corresponding side is 5 meters. We don't know anything about the sides on the right-hand side. So these two that are marked with the X, we don't have any dimensions for those. So we're not even going to consider those when we do our analysis. Over on the right-hand side, the ones that are marked with the squiggles, in the small triangle, we've got a side that has a length of 3. This big long side, going from the top all the way down to the bottom, is X plus 3. Okay, and these two sides, those two portions added together. All right, this is the proportion that we want to solve. And we can solve this the same way we've been solving any of the other ones. We can cross multiply. The only trick here is that when we cross multiply by the X plus 3, we're going to get 2.0 times X plus 3. And just to write it out explicitly on the other side, we're going to have 3 times 5. On the left-hand side here, we have to use the distributive property. So 2 times x is going to give us 2x. 2 times 3 is going to give us 6. On the right-hand side, 3 times 5 is just 15. Now we just want to solve for x. I can subtract 6 from both sides, get 9, divide both sides by 2. X is going to be 4.5. All right, one last thing about similar triangles. We've been talking about the ratio of the lengths of the sides. There's also a relationship between the areas of the two triangles that are similar. So in similar triangles, the ratio of the areas between our two triangles is equal to the ratio of the sides squared. Okay? And this kind of makes sense because the ratio of the sides, you're comparing two lengths. If you're going to calculate an area, it's like a length times a length. So we're squaring those. So here we want to find the area of triangle DEF. And we can see that triangle DEF is similar to triangle XYZ because they've matched up the corresponding sides for us. So let's start by figuring out what is the ratio of the sides between our two triangles. So we can write this as, let's do it as large over small. Okay. It's going to be in our large triangle, we have 10 meters. And in our small triangle, we have 4 meters because this side and this side are corresponding. Now, if we want the ratio of areas, okay, again, we can set this up large over small. Let's fix that, large over small. So the area of our large triangle is going to be the area of triangle DEF. Small triangle is the area of triangle XYZ. Okay. We know that this is equal to the ratio of the sides, so 10 over 4 squared. Now, we know the area of one of our triangles. We know that the area of triangle XYZ is 16. So we can sub that in there. Area DEF is equal to, and we know from our rules of exponents here that if we've got something in brackets with the exponent on the outside, we apply the exponent to both, in this case, the 10 and the 4. So 10 squared is 100, 4 squared is 16. Now, if we want to solve, we're just going to, again, cross multiply here. So cross multiplying this is going to get, well, if we just multiply across on, we're going to have to multiply by 16 and then divide by 16. So the area of triangle DEF is going to be 100 meters squared.